Okay, so as if the last video wasn't enough, we need to recall that a rectangle with base b and height h has an area of base times height. So again, if you didn't know this before, don't panic, we're going over it now, right? But if we have this rectangle here that maybe has a base of b and the height of h, its area is going to be equal to the base times the height, okay? You may hear people say length times width. Well, they're just referring to the same thing. Okay, well, it says that we can actually use this area addition postulate that we discussed in the previous video to see that a parallelogram has the same area as a rectangle with the same base and the same height. Okay, and the way that they do this is, you know, we can take, if we take this parallelogram, first of all, we need to understand that these sides are actually parallel. Okay, so if this is a right angle, that means this is a right angle. And all we're going to do is just go take this triangle and we're just going to move it over here, okay? And what we end up seeing is that, you know, this rectangle is formed, okay? And so it's actually going to be the exact same figure, okay? If we cut off that triangle and move it over to the other side, okay? So pretty simple, okay? And now we're going to take a look at just the actual diagram. So again, as you're taking notes, make sure that you get this in your notes. Okay, the area of a parallelogram with base b and height h is area equals base times height. Okay, again, this is something that you need to get in your notes. Okay, and actually draw the picture, use a geometry template, all those good things. Okay. Also, we must remember that that rectangles and squares are also parallelograms. Okay, we talked about that last semester when we started classifying all these different quadrilaterals. Okay, the area of a square with side S is area equals side squared, and the perimeter equals 4 times the side, or the side plus the side plus the side plus the side. Okay, or I'm just going to write S plus S plus S plus S is actually the same thing. Okay, and one last important thing to remember before we get started with a couple of problems here is that the height of a parallelogram is measured along a segment that is perpendicular to the line containing the base. Okay, it's important to remember that this actually has to be perpendicular when we are doing these measurements. Okay, so for example, if you look at our picture right here, okay, this part right here, okay, this little dotted line is perpendicular to the base, and it shows by that right angle. Okay, so it's just important to remember that. Now let's take a look at a couple of example problems here. Okay, it tells us to find the area of the parallelogram. Okay, so when you look at the parallelogram, it looks like it has a base of 11. Okay, it's got like this you know, one side length of 34, which I guess would mean that this side length is also 34. So maybe it might be important to write that down. Okay, it would also mean that this side length right here is also 11. These are just the properties of parallelograms. Okay, and we now want to find the height of this parallelogram. Now it does us a nice favor here, and it tells us that this distance right here is 30 or 30 millimeters. Okay, and so that's definitely nice to know. Okay, and so now I'm looking at this entire problem here. Like, I just want to find the height of this particular parallelogram. Okay, so that's what I'm going to write down. First, I'm going to find the height of the parallelogram. Okay, and I'm going to do that by the Pythagorean theorem. We see that we have a right angle here. We know one of the legs, and we know the hypotenuse, and so we want to figure out the other leg. So I'm going to say that this is going to be now 30 squared plus b squared equals our hypotenuse squared. That's 34 squared. Okay. Now at this point, I'm going to figure out what is 30 squared and what is 34 squared. Okay, so 30 squared is going to give me 900. So I'll say 900 plus b squared is going to give me 34 squared, which is 1,156. Okay, I'll subtract 900 from each side to get that b squared is now going to give me 256. Okay, and then I'll take the square root of each side to give me that our b value, or this other leg here, is actually going to give us 16. Okay, and so again, that is this particular height right here. And so we can conclude that our height of our parallelogram here is actually 16 millimeters. Okay, so now this is really simple. Okay, I'm going to go ahead and calculate the area because now we know the base of the parallelogram and the height of the parallelogram. So I'm going to say find the area of the parallelogram. Okay, well, the area is just going to be equal to the base times the height, which we know both of those. So I'm going to say that the area is equal to the base, which is 11, times the height, which is 16. Okay, and I'm just going to take 11 times 16 in my calculator, and that gives me 176. So I'm going to say the area of the parallelogram is 176 square millimeters. Okay, so again, we're starting with hopefully a fairly simple problem. In the next video, we'll take a look at 3 more examples.